All right, just a couple more minutes. We got rudely cut off. All right, you have a 10 molar stock concentration of sodium hydroxide. You need to make 400 milliliters of a 2 molar solution. How much of the stock do you need to add, and how much water do you need to add?
Okay.
Do we have to change the milliliter to liter?
No.
Okay.
As long as the units are the same, our molarity and molarity are going to cancel out, so we can be with whatever volume we've got.
Got it.
All right, so what we need to do is we need to set up our concentration side and our stock side and figure out where our variable goes. So we've got our 10 molar stock. We want to find out how much of that we're going to need, so that is our variable of a x.
Okay.
And then we've got our 2 molar, and our volume is 400. So we got to get x alone, so 2 times 400 divided by 10 is going to give us 80.
Okay. 80, and our units are milliliters.
All right, so we need 80 milliliters of our stock NaOH.
Okay, so that's this first part.
Yes.
We already know that.
But we want to make a total solution of 400 milliliters.
Yes.
That only gives us 80.
Right.
So we're going to have to subtract and figure out how much water we got to add to that.
Yep.
So 400 minus 80, and we're left with, you are a genius. I didn't even have to say it. You were already there.
And this is water.
Yep.
Over here, this is milliliters of sodium hydroxide.
Okay.
So you really have 2 answers here. Whoa. Answer 1.
Oops.
And answer 2. I make really good squares at
you do.
7:40 at night. Okay. Dilution example number 2.
All right.
This one we love because you know what? This is what you make us do every day.
Crazy?
We have a 12 molar stock concentration of hydrochloric acid.
All right.
And we need to make enough for 24 lab groups.
Okay.
So 2 chemistry classes.
All right.
Each of the groups need 150 milliliters of 0.5 molar solutions.
Okay.
And we need to add an extra 150 milliliters for spills.
At least, usually.
At least. I might add 300. But we're going to do 150 extra. So basically, we're making enough for 25 lab groups. So let's figure out number 1. What is the total volume needed?
Okay, so we got to take 150 times 25.
Yes. What does that give us?
That a lot. 3,750 milliliters.
Okay.
That's
Or
a lot of milliliters.
3.75 liters.
Wow.
If you wanted to reduce it to liters.
Okay.
Okay, how much of the stock concentration do you need to add? So this is when we set up our dilution equation.
Okay, so our stock is 12 molar, so we got our 12. How much we're going to need is our X in milliliter. Our total, we want 0.5 as our dilution, 0.5 molar. And then we've got 3,750 milliliters. That is a long time.
Okay, get over it.
Okay, I got it. All right. 0.5 times 3,750 divided by 12 is going to give us 156.25 milliliters of hydrochloric acid. So we need that much of our stock.
Okay, so not very much compared to how much we needed because it's very concentrated and we are going down to a very small dilution.
Okay.
Okay, how much water?
So we got to take our total volume, subtract out how much hydrochloric we were going to need, and that leaves us with how much water we're going to have to mix together.
So 3,750 minus 156.25 gives us
3,593.75 milliliter.
So really, if we were doing it, we'd probably round that.
Yes, we would, because doing a
it would be
0.5
close
milliliter
enough.
is hard to do in a graduated cylinder. Hello, 0.5, drop.
Okay, so notice we asked for a lot in this question. You may have something similar to it in the future.
Yeah.
Most of the time, if you're asked for how much stock concentration do you need, you'll also be asked how much water do you need to make the entire thing.
Yeah.
All right, that is the end of section 2. Hope you enjoyed it, and then you can do all the different concentration things.
You'll get lots of practice.
Oh, yeah.
It'll help.
Bye.